Okay, so this is where we left it in class, is that we had gotten to the point where we could say mg minus bv, this net force, is equal to ma, where we wrote a as dv dt, and so this is a differential equation that you can solve. Okay, let's do that. Okay, that's what we started with, mg minus bv equals m dv dt. So one of the goals is that we want to get dv dt by itself. That's the first step. So there it is. I divided both sides by m. So I get a nice little g minus b over mv. Okay. So next step, we have two variables, v and t. And we want to separate them. So from calculus class, you might have heard of separation of variables. That's what we're doing. So we're going to separate them. So we have a v on this side and a v on this side. So we want to get those on the same side, but we want them not to be on the same side as t. Okay, so this is what we get. So bring dt up here and bring this guy down here. And so now we want to integrate. Okay. Now it's time for u sub, right? So I think you just learned this. For those of you who are in calculus right now, just learned this like yesterday or something. And so we want to let this whole bottom thing be u. So u is g minus b over m times v. So I'm just making a u sub. So I'm just saying that whole quantity down there is u. Okay. So the next step when you're doing u sub is you need to then say, well, what's du? Okay. So du, the g is a constant. It's just negative b over m times dv. Okay, so that was our next step. We define u, we do du, but then we look back at our equation. Do we have du? No, we have dv. So I want dv in terms of du. So here's my equation. Du is negative b over m dv. I'm going to solve for dv. So dv is negative m over b du. So that dv is going to go in there. All right, take a breath. And let's do it. So there's my dv, and now that whole guy down there is u. So this looks a little bit better. But a question that I have right now is I'm doing an integral, right? So do I want limits or no limits, right? Do I want a definite integral or an indefinite integral? And there's two ways of doing these kinds of problems. You can either do no limits, right, an indefinite integral, and then find the integration constant by applying initial conditions, okay? Or you can integrate dv. So if we were back up here and we put our limits, it would go, our v would go from v naught to v of t, and our time would go from 0 to t. And I think in the Edpuzzle I gave you, he used v prime and t prime, and I think that's unnecessarily complicated. This when you do it this way, when you call it v of t and then just t, once you get done with the math, the v of t is just staring at you. So this is my favorite way of doing it. Okay, so those are our choices. By the way, before I leave this page, oops, let me move me. When you look at other ways of doing this, you might also see instead of this equation, you can rearrange this and get 1 over m dt, right? If you divide the whole thing, right, by m, then that's how we got this. But from this first guy, you can also rearrange it in this way. And some people like it better this way because the u is not as scary looking because it's just negative b dv. Either way, however you want to rearrange it is fine as long as you separate the variables appropriately and do the u sub. Okay, so I'm just here to show you a couple other ways you might see it. Okay, groovy. So this is the equation that we ended with. negative m over b, integral of du over u equals the integral of dt. Okay. So my favorite way I don't like to do the indefinite integral. I like to do the one with limits, like I was telling you. But right now I'm integrating with respect to u. So I don't want to put limits here because then they have to actually be like the value of u at 0 and the value of u at t. And so that's just unnecessarily annoying. So I'm just going to wait until I get back in V land, and then I'll throw my limits in there. Okay. So, oh, hold on. Oh my goodness, something crazy just happened. This all looked nice, and then kapow. Okay, step by step. A few things happened here. Number one, the integral of 1 over x is natural log. Okay? Oopsies. So there's your green. So the integral of 1 over x dx is the natural log. In physics, often I just say log when I mean natural log. Okay? So it's the natural log of u. And u was g minus b over m v. So that's all that happened with this green box. Okay? It's just integral of 1 over x was log of x. And then instead of writing u, I went back into v land. Okay? All right. The second thing that happened was that I threw my limits in here. My limits of my dv integral were from v naught, whatever my initial velocity was, to v of t. Okay? That's all that happened here because I did the integral, and so I wanted some limits. And then my limits of my dt were just 0 to t. And the integral of dt is just t. Okay. So take a breath, make sure that that makes sense. And if you want to look at it sort of cleaner again without the stuff. Okay? Okay. So there they were. But I want to really make sure that you understand how these limits work. Okay? That initial limit that was at time equals 0, the v was v naught. It's very important that those match up. And then at time t, the velocity is v of t, v at that value of t. Okay? So if you were actually asked for like information about the velocity at a particular time, like 2 seconds, right? And then you would talk about that would be 2 seconds right here, and this would be v at 2 seconds. Okay, so hopefully that's all gelled in your head. Perfect. So now moving forward, I'm evaluating at my limits, right? And then of course subtracting. So this is my value at my top limit, v of t, minus my value at my bottom limit. Now, what did I do here? 0 instead of v naught because I dropped it from rest. Okay, so I can put in my 0 as my v naught there. So I plugged in my limits and I applied v naught equals 0 because I dropped it from rest. All right, next step. Oh, and what did I do to the right hand side? I just did t minus 0. Cool. So if that's times 0, then that part goes away. And so this right hand guy is just log of g, right? Now, do you remember that the log of a minus the log of b equals the log of a over b? I hope so, because I just used it. I had the log of this stuff minus the log of g. And so I turned that into log of g of that crap divided by g. Okay. Cool. Hopefully you are still following me. And what's nice about a video is that you can go back, you can pause, you can watch this again if you need to. Okay? Now I'm taking my negative m over b, I'm moving it to the other side because my point is that I want to get the natural log all by its lonesome so that I can throw an e down here and get rid of it, right? That's a glorious thing. Okay, that's that. I'm going to take that equation and move it up to, oopsies, up to the next slide. And now I'm going to throw an e down there. So I'm raising e to the power of both sides. Okay? So that's glorious because my left-hand side, that e gets rid of that natural log, and I just get whatever was in the parentheses right here. And then I get e to the negative b over m times t. Groovy. All right, I'm going to simplify. Oh, sorry, I used the fact that e to the log x is equal to x. I forgot that I was like nicely writing all of my reasoning over here. Okay, next is I'm just going to simplify this fraction. Okay, so it's 1 minus, now we get b over mg times b of t equals same thing on the right-hand side. So we are just a simple amount of algebra away to solve for v of t, because that was our goal. We wanted to solve for v of t. And so, da-da-da, there it is. That is the equation for the velocity as a function of time t for an object that was dropped from rest. Okay? Now, are you going to memorize this? No. You are going to need to derive it, right? And remember, the rest of these slides are where I'm like showing you how these look, right? So you should go through like the rest of the slide deck and make sure that all that gels nicely. But the point is that this strategy of solving, you should now be able to apply to any thing that kind of looks like that. Okay? You might have problems with just a resistive force, in which case, instead of mg minus bv, it just might be negative bv equals m dv dt. Okay, and one of your homework problems actually takes you through a question like that. But it uses that same separation of variables and u sub. Okay, so email me if you have any questions. See ya.